Hello, Math 005. What we're looking at in this lesson is 3.6, which is the slope-intercept form. We have three objectives here: graph using the slope-intercept form, equations in slope-intercept form, and then we're also going to start our talk about parallel and perpendicular lines. The first example, draw a line that has a y-intercept of 0, -1 and a slope of 3/4. Well, it tells us that we have a y-intercept of 0, -1. So first thing we're going to do is plot that point 0, -1. So that's over 0, down 1. It's going to be that point right there. Now it tells us we have a slope of 3/4. Think of that as rise over run. Now, if there were a negative, instead of rising, we'd actually drop. But regardless, you always run to the right. So always run to right. The negative just determines whether we move up or down. In this case, it's positive. So from the y-intercept, we go up 3, 1, 2, 3, and then to the right 4. 1, 2, 3, 4. And then we plot our point. And then we always want to make sure we use a ruler, and we're going to connect our two dots. It looks like, yeah, that looks like about close. Extend our line out, and then we always want to make sure we put ends on our line. And there we have the line. It has a y-intercept of 0, -1 and a slope of 3/4. And again, if we kind of draw the little triangle out, we can see that it has a change in the y value of a 3 and a change in the x value of a 4. So we have this, the slope-intercept form for a line is going to be, and you probably have heard this before, y equals mx plus b. That is the slope-intercept form. So if you were told to answer in the slope-intercept form, that's the form you want to go to. The b, this is going to be our y-intercept. Think b stands for begin. And our m here, this represents our slope. You can think of our m, it's what we move. So b is where we begin, m is how we move. Now when we are substituting numbers in, we're going to leave the x and the y alone, and then we're putting numbers in for the m and the b. So the next three examples of this one, we're all part of example 2, is finding the slope and the y-intercept for the following lines. Before we're able to identify the slope and the y-intercept, it must be in this slope-intercept form. You have to have the y solved for entirely before you can identify the slope and the y-intercept. So for the first one, y equals 3/8 x minus 2. This is in the form of y equals mx plus b. It is in the slope-intercept form. So therefore, we know that our slope, our m, is always going to be the coefficient of the x. So the slope here is 3/8. Keep in mind, it's not 3/8 x, it's only the coefficient of 3/8. Now, we will have to answer the y-intercept. Remember, the y-intercept is always going to be a point. So therefore, the y-intercept here, it's going to be the point, and it's always 0, and then in this case, -2, because that's what we have there. So there is our answer for that one. Now on to letter B. When we look at B, 3x plus y equals 7, we notice that that's in standard form because the x and the y are on the same side. First thing you have to do is solve for y. We want to get the y by itself, so we need to subtract a 3x from both sides. Now we have y equals, it doesn't matter if you write the 7 or the -3x first. I'm going to write the -3x just to keep it in the slope-intercept form. The 7's positive, so just put plus 7. Now we have it in slope-intercept. Now we can say, okay, well, there's our slope and here's our y-intercept. So our m is just a -3, and here our y-intercept would be 0, comma, and then a positive 7. Go ahead, pause the video, take a moment, and I want you to try letter C. You'll notice that you will have to solve for y first, and then identify your slope and your intercept, then check your answer with mine. Okay, you will notice the first thing I did here was I subtracted a 4x from each side. Then I was left with -5y equals -4x plus 10. And then I divide everything by a -5. So we get left with y equals 4/5 x, and that would be -2. So therefore, our slope is 4/5. Our y-intercept is 0, -2. The next one we are looking at. Example 3, find the equation of a line that has a y-intercept of -2 and a slope of -3 over 2. Pause the video and try this one out on your own. See how you make out. Okay, you can see find the equation of a line. We know that's going to be y equals mx plus b. Has a y-intercept of 0, -2. We know that is going to be our b, and a slope of -3 over 2, which is our m. So we're simply going to substitute in our b and our m into our slope-intercept form. So y equals -3 over 2x plus our b, which is -2, so just -2. And you will notice when I wrote my slope, I put the negative in front of the 3/2. It doesn't matter the placement of that negative. Keep in mind, you can write a fraction 3 different ways with that negative, and all of them mean the same thing. You can have it in the numerator, denominator, or out in front. When we're working with these kinds of problems, typically we'd write it in the numerator, like we see here, just because that's going to tell us to move down instead of up. Okay, moving on to the next page. We want to graph these. So the first one, graph y equals 2x plus 4. Since this is in slope-intercept form, it makes it very easy to graph. Think y equals mx plus b. So here our slope m is 2, and our y-intercept is 0, 4. So let's start with 0, 4. Over 0, up 4. Now our slope is 2. If you knew 2, think of it as 2 over 1. Since the 2 is positive, that means from the y-intercept we're moving up 2 places over 1. Now we're going to fall off the graph. Since we went up and right, you could also go down and left once you have your first 2 points, just so you could continue that. And I'm going to do that a couple times, going down 2 over 1, just so we can get a lot of points on this graph here. And then I'm going to take my ruler again and line it up as good as I can. Oop, there it's a little off. Well, it might be as good as I can get it using this, but we'll... And then we put our ends on our line, and we have it. Okay, now looking at this next one, graph 3x plus 4y equals 12. Now, in order to graph this using the slope-intercept form, we need to solve for y first. So solve for y first. So first thing we do is subtract the 3x over. So therefore, I'd be left with 4y equals -3x plus 12. The next step is to divide everything by a positive 4. So we're left with y equals -3/4 x, there's our slope, and then plus 12 divided by 4 is 3. So here our slope is -3/4, and our y-intercept is 0, 3. So I'm going to start with the 0, 3 first. So that would be this point right here. And then from there, we're going down 3 places, 1, 2, 3, and over 4. 1, 2, 3, 4. And then we have those 2 points there. And then what we want to do is graph our line and put our ends on our line, and there's our line. Example 6, determine an equation for the graph shown. What I want you to do is pause the video and then look at this graph, think of the form y equals mx plus b, and see if you can create an equation in that form from this line. So like I said, go ahead, pause the video, and give it a shot. Okay, let's walk through this together. Well, looking at this graph, we see that this point right here is going to be our y-intercept because it's touching the y-axis. And we see that point there is going to be the point 0, 5. So right away that we know is our b here is going to be a positive 5. Now we have to figure out what our slope is going to be. You can work through this one of 2 different ways, really. We know this point is 0, 5. We can see that this point here is 45, comma 2. So you could use the slope formula and do the y2 minus y1 divided by x2 minus x1, or in this case, since we have a picture, we could count our blocks. We just want to be very careful when we count blocks because we have to look at the scaling and how these blocks are being counted. So to go, I'm going to count the blocks just so we can see how it works here. And I'm going to count, so you can see that this counts by half. So we know that this is going to be 1, and then 2, and 3. So our m is going down 3 places. And I put -3 because we're moving down. Now when we move to the right, we'll see we're moving over 1, 2, 3 blocks. However, each block here has a 15-minute increment. So it's going over 15, over 30, and over 45. So it's -3 over 45 here is for our slope. But then what we have to do is reduce that fraction. So we want to know, because we know 3 goes into 45, so we have to figure out, okay, well, how many times does 3 go into 45? So go ahead, pause the video, take a second, reduce the fraction, and then see if you can finish writing this if you haven't yet. Okay, so we found here the equation should be y equals -1/15 x plus 5, because we have that -345, which simplifies to -1/15. And we know that 5 came from the y-intercept of 5. You can see that over here on the right, I also used the formula for slope and found the slope that way as well by doing the y2 minus y1. The next thing, parallel and perpendicular lines. We're going to actually, before we fill in these two bullet points right here, we are going to look at example 7 first. Determine if the graphs of y equals 3/2 x plus 3 and 3x minus 2y equals -5 are parallel. Let's first start by graphing both of these. So we want to graph this, and then let's also graph this one as well. Well, the first one that we are going to graph, 3/2 x plus 3. Let's start with our y-intercept of 3, and then we go up 3 over 2. We're going to fall off the graph, so I'm going to actually go down 3 and then left 2, just to keep more points plotted. Okay, so then what I'm going to do is draw my line in here. Give me a second. And we have our line drawn. So now what we want to do is I'm going to work through this next one in red just so we can see the difference. We want to graph this one. However, before we graph this, we need to solve for y first. So we need to solve for y first. That's going to be something you want to get into the habit of doing with a lot, with a lot of your equations, because in order to identify parallel perpendicular lines, we have to do this. In order, it makes it easier to graph. So the first thing is subtract a 3x from both sides. So we get -2y equals -3x minus 5, and then divide everything by -2. So we get y equals 3 over 2x plus 5/2. So we know 5/2 is the same as 2.5. So we're going to start at 2.5, someplace right in here, and then 3 over 2. So we go up 3, 1, 2, 3 over 2. Oops. 1, 2, 3 over 1, 2, and it's going to be someplace right in there. Now, if we were to continue that, you'll see that when we graph this, we can kind of squeeze it in right here. You can see that these two lines are going to be parallel because we know parallel lines never cross. Now, when we inspect these equations, so looking at this equation in purple and this equation here in purple, what do you notice that they have in common? Right, they have the same slope. So that's one of the first characteristics that we know about if two lines are parallel. They have the same slope. The other thing is they must have different y-intercepts. If they have the same y-intercept, then they would be the same line. So they must follow these two characteristics in order for them to be parallel. But before you can determine if they're parallel, you must, like I said, you must solve for y first. Any problem that you're working with, if it's talking about parallel or perpendicular lines, you always want to solve for y first. Okay, moving on to the last page here. Now we want to know, how can we tell if two lines are perpendicular? So now we want to talk about perpendicular lines. Let's go ahead and do the same thing we just did by graphing each of these lines in the space provided. So let's start with the first one. Again, we have to solve for y first. Solve for y. So we subtract a 3x from both sides. So we get negative 2y equals negative 3x plus 1. And then we divide everything by negative 2. So we get y equals 3 over 2x minus 1/2. So we start at negative 1/2 and then 3 over 2. So we're going up 3 and then over 2, someplace right in there. Okay, and then let's draw our line here. Oh, that one got a little crazy. And now let's look at this other one. This one's already in slope-intercept form, so let's go ahead and graph those. So negative 2/3 x plus 1/3. Ooh, this one's getting a little tricky to graph because of the fractions here, but okay, so we'll say 1/3 someplace right in there, and down 2 over 3. 1, 2, 1, 2, 3, someplace right in that vicinity. And then, ooh, you will notice then that even though this is just a rough sketch, that we can see that these lines do appear to be perpendicular, meaning they cross at 90 degrees. So now when we look at these two equations, so when we look at this equation here and this equation here, we're not going to be concerned with the y-intercepts. They could have the same y-intercept or they could have different y-intercepts. We don't care about that. However, we're concerned with their slopes. If you notice their slopes, one is a negative 2/3 and the other one is a 3 over 2. The things we can say here, how can you tell if they're perpendicular? They're what we call opposite reciprocals. Opposite meaning one's negative and one's positive, and reciprocals meaning the numerators and denominators are switched. So you inverse them. So 3 and 2, you flip them over. The other thing we know with these is if we were to multiply these two things together, we'd get a negative 6 over 6, which equals a negative 1. Their product always equals negative 1. Their product, there meaning the slope, is negative 1. So the slope of their product is negative 1. Or you want to think opposite reciprocals. One's negative, one's positive, and then they have to be flipped over. And that's how we know if they're perpendicular. Again, you must solve for y first. Okay, a couple last examples here. Write a slope-intercept. So right away we know our answer has to be in the form y equals mx plus b for the line whose graph is described. Has to be parallel to this, but with this y-intercept. So we know that this is going to be our b, if you will, because it's telling us that's the y-intercept we're looking at. So if we have y equals mx plus b, if this is going to be our answer, we know that this plus b, we want it to be a negative 5. Okay, now we just need to figure out what our slope is. Well, if we parallel means that we want them to be the same. So the slopes have to be the same. So we need the same slope, but we need to find the slope of this. So what do we have to do? We have to solve for y. Because parallel means same slope and different y-intercepts. So let's see, to solve this, we'd subtract 4x. We get negative 5y equals negative 4x plus 3. Divide everything by negative 5. We get y equals a positive 4/5 x minus 3/5. So we need that same slope of 4/5. So this is what we're looking at, the 4/5. And we want to put that in for our m here. So instead of m, get rid of part of my arrow here, we are going to write 4/5 minus 5 because that's what we want our y-intercept to be. Okay, the next one. We want it to be perpendicular to the graph of this. Remember, perpendicular, you want to think opposite reciprocals, perpendicular to this graph with this y-intercept. Again, y equals mx plus b. But we know here that instead of plus b, we want to use a -5. However, we need to find our slope. Now, this is the same equation that we just looked at from above, so I'm just going to rewrite it. Y equals 4/5 x minus 3/5. Now, we said that for a perpendicular line, it has to be the opposite reciprocal. So this equation here has the slope of 4/5. However, we want to find the perpendicular slope. So first thing, you have to take the reciprocal, which would be 5/4. And then you have to take the opposite of that. And since that one's positive, we make it negative. So that means that our perpendicular slope would be a negative 5/4 x minus 5. Now, a way you could check your answers here is you could take this equation right here or this one right here and graph it in your calculator. We did this before we went on spring break, so you should be familiar with how to do that. If you forget, send me an email or you can Google graph a line on the TI-84 Plus. Go to the y equals button and just type those into your calculator. And then so to do that, so we type that in y1 and then graph. And then if you hit the trace button, you can type then the x value of 0 and then hit enter, and you should see the y value become -5. And then you do the same thing with the bottom one. Hope this video helps you with 3.6. If you have any questions on the homework, please reach out and let me know. Have a great one. Bye.